A giant leap for humankind. British footprints on the moon and beyond. Space. The final frontier. It's a realm that has fascinated and inspired generations, a vast expanse that beckons with the promise of discovery and adventure. It's a phrase that echoes through history, a testament to our innate human desire to explore the unknown. From the earliest days of stargazing to the modern era of space travel, humanity has always looked to the skies with wonder and ambition. While the image of Neil Armstrong's first steps on the moon is etched into our collective memory, few realise the significant role Britain played in shaping the space age. British scientists and engineers contributed to the technology and knowledge that made such monumental achievements possible. This island nation, known for its explorers and innovators, has left its mark on the cosmos, from the earliest theoretical frameworks to cutting-edge space technology. The legacy of British exploration extends far beyond the terrestrial, reaching into the very fabric of space itself. This is the story of British space pioneers, the men and women who dared to dream of reaching beyond the bounds of Earth. Their contributions laid the groundwork for many of the advancements we see today in space exploration and technology. It's a story woven into the very fabric of British history, a narrative that combines scientific brilliance with unwavering determination. From the laboratories of Cambridge to the launch pads of Cape Canaveral, British minds have been at the forefront of space innovation. These are the tales of individuals who, armed with ingenuity and fueled by a thirst for discovery, propelled humanity towards the stars. Their relentless pursuit of knowledge and their pioneering spirit have been instrumental in pushing the boundaries of what is possible. This journey takes us from the heart of scientific revolution to the cutting edge of space exploration, revealing the often unsung heroes who helped humanity take its first steps into the great cosmic expanse. Their stories remind us that the quest for knowledge and exploration is a universal endeavour, one that transcends borders and unites us in our shared curiosity about the universe. The father of British rocketry, Isaac Newton, and his enduring legacy. Our journey begins not on a launch pad, but in the quiet contemplation of a Cambridge scholar. It was here, amidst the ancient books and manuscripts, that Newton's insatiable curiosity and relentless pursuit of knowledge began to take shape. Sir Isaac Newton, a name synonymous with gravity, laid the very foundation for space travel with his groundbreaking work in the 17th century. His contributions to science are vast and varied, but it is his laws of motion that have had the most profound impact on our understanding of the universe. Newton's laws of motion, published in his seminal work in 1687, provided the fundamental understanding of how objects move in space. These laws, simple yet powerful, describe the relationship between a body and the forces acting upon it, and the body's motion in response to those forces. His third law, stating that for every action there is an equal and opposite reaction, forms the very basis of rocket propulsion. This principle is what allows rockets to lift off the ground and travel into space, overcoming the pull of Earth's gravity. While rockets wouldn't become a reality for centuries, Newton's work provided the theoretical blueprint. His ideas were so ahead of their time that it took generations of scientists and engineers to fully realize their potential. He envisioned a cannon firing projectiles with ever-increasing velocity, ultimately escaping Earth's gravitational pull. This thought experiment, known as Newton's cannonball, illustrated the concept of orbital motion and laid the groundwork for our understanding of how satellites and spacecraft orbit the Earth. This thought experiment, though simple, planted the seeds for future generations of scientists and engineers. It inspired them to think beyond the confines of our planet and to dream of exploring the vast expanse of space. Newton's influence extends beyond his laws of motion. His work in other areas of science, such as optics and mathematics, has also had a lasting impact. His development of calculus, for example, provided the mathematical tools needed to describe the motion of objects in space. His work on optics led to the development of reflecting telescopes, which revolutionized astronomy and allowed us to peer deeper into the cosmos. These telescopes, which use mirrors to gather and focus light, have become essential tools for astronomers. His contributions weren't just theoretical, they provided the tools and the understanding that would ultimately enable humanity to reach for the stars. The principles he discovered are still used today in the design and operation of spacecraft and satellites. Newton's legacy serves as a powerful reminder that every great journey begins with a single step, or in this case, a single equation. His work has inspired countless scientists and engineers to push the boundaries of what is possible and to explore the unknown. His work, a testament to the power of human curiosity and ingenuity, continues to inspire generations of scientists and explorers. As we look to the future of space exploration, we stand on the shoulders of giants like Newton, whose contributions have paved the way for our journey to the stars. Reaching for the stars, the British Interplanetary Society and the Dawn of Astronautics. As the 20th century dawned, the dream of space travel began to transition from the realm of science fiction to the cusp of reality. The early 1900s were a time of rapid technological advancements and burgeoning curiosity about the universe beyond our planet. Science fiction writers like H.G. Wells and Jules Verne captured the public's imagination with tales of interplanetary voyages, planting the seeds of what would eventually become a serious scientific endeavour. In 1933, a group of visionary enthusiasts gathered in Liverpool, united by a shared ambition to explore the cosmos. These pioneers were not just dreamers, they were thinkers and doers determined to turn the fantastical ideas of space travel into a tangible reality. They believed that humanity's future lay among the stars, and they were committed to making that future a reality. This marked the birth of the British Interplanetary Society, BIS, the oldest space advocacy organisation in the world. The BIS quickly became a hub for those passionate about space, providing a platform for sharing ideas, conducting research, and advocating for the exploration of space. Their meetings were a melting pot of creativity and scientific inquiry, where the boundaries of what was possible were constantly being pushed. Founded by Philip E. Cleator, a science fiction writer, the BIS brought together engineers, scientists and artists, all driven by a passion for space exploration. Cleator's vision was to create a society that could bridge the gap between science fiction and scientific reality, and he succeeded in attracting some of the brightest minds of the time. These individuals were not only experts in their respective fields, but also shared a common dream of reaching beyond the confines of Earth. This pioneering group tackled the challenges of spaceflight decades before Sputnik or Yuri Gagarin. They delved into the complexities of rocketry, propulsion, and the harsh environment of space, laying the groundwork for future space missions. Their work was not just theoretical. They conducted experiments, built models, and tested their ideas, often with limited resources but boundless enthusiasm. One of the BIS's most notable contributions was the development of the lunar lander concept in the 1930s. This was a time when the idea of landing on the moon was still considered science fiction by many, yet the BIS members were already envisioning the technical requirements and challenges of such a mission. Their designs were ahead of their time, showcasing a deep understanding of the complexities involved in lunar exploration. Their design, strikingly similar to the Apollo lunar module, demonstrated a remarkable foresight into the technical challenges of landing on the moon. This foresight was not just a stroke of genius, but the result of meticulous research and collaboration among the BIS members. They anticipated many of the issues that would later be encountered by NASA engineers, proving that their early work was not only visionary but also scientifically sound. They even built and tested a model lunar lander, a testament to their commitment and ingenuity. These tests were rudimentary by today's standards, but were groundbreaking at the time. They provided valuable insights and data that would inform future space missions. The BIS members' hands-on approach and willingness to experiment were key factors in their success. The BIS played a crucial role in shaping the future of space exploration by fostering collaboration, sparking public imagination, and laying the intellectual groundwork for the space age. They organized conferences, published papers, and engaged with the public, spreading their enthusiasm for space far and wide. Their efforts helped to create a culture of curiosity and innovation that would drive the space race in the decades to come. Their unwavering belief in the possibility of space travel helped inspire a generation of scientists, engineers, and dreamers. The BIS's influence extended beyond their immediate circle, reaching young minds who would go on to become the pioneers of space exploration. Their legacy is a testament to the power of vision and perseverance in the face of seemingly insurmountable challenges. Their legacy serves as a reminder that even in the face of seemingly insurmountable challenges, passion and collective effort can pave the way for groundbreaking achievements. The story of the British Interplanetary Society is not just a chapter in the history of space exploration. It is a beacon of inspiration for all who dare to dream big and reach for the stars.